In this section, we are going to talk about remainder theorem. What is remainder? Let's try to understand this through some example. If I divide 15 by 6, I can represent 15 by 6 as 6 multiplied by 2, which gives you 12, plus 3, which gives you 15. So when you divide two numbers, you can represent them as dividend equal to divisor multiplied by quotient plus remainder. And what is left is called remainder. In this example, 15 by 6, when we divide 15 by 6, we get 6 multiplied by 2, where 6 is my divisor, 15 is my dividend, and my remainder is 3. When we divide 15 by 6, we get quotient as 2 and remainder as 3. Similarly, when you try to divide 12 by 6, you get 12 by 6 equal to 6 multiplied by 2 plus 0. And hence, in this example, your quotient is 2, but remainder is 0. And whenever you get remainder as 0, you can say 6 and 2 are factors of 12. Now let's take an example of polynomial divided by polynomial. So when you try to divide 3x squared plus x plus 1 by x, you can represent this as divisor x multiplied by 3x plus 1 and remainder plus 1. Here your quotient is 3x plus 1 and your remainder is 1. This gives you an indication that polynomial 3x squared plus x plus 1 cannot be fully divided by x, and you will always get some remainder when you try to divide it by x, and in this case the remainder is 1. Let's take another example of 2x cubed plus x squared plus x and divide it by x. What do you get? You get 2x squared plus x plus 1. No remainder in this case. When we divide by x, we get quotient as 2x squared plus x plus 1, but we do not get any remainder here. This gives us an indication that x, which is a divisor, and 2x squared plus x plus 1, which is your quotient, are really factor of 2x cubed plus x squared plus x, which is your dividend. Now, find out remainder when x to the power 4 plus x cubed minus 2x squared plus x plus 1 is divided by x minus 1. So I got two polynomial and I'm trying to divide one with other. In this example, how do I find out when I divide two polynomials together, right? So my step 1 would be, let's find out 0 of a polynomial which is your divisor. In this example, x minus 1 is divisor, so I'll try to find out 0 of x minus 1. So x minus 1 equal to 0, which implies x equal to 1. Next, I'm going to put the value of x as 1 in dividend x to the power 4 plus x cubed minus 2x squared plus x plus 1. And when I replace x by 1, I get 1 to the power 4 plus 1 to the power cube minus 2 multiplied by 1 to the power 2 plus 1 and plus 1, which gives you 1 plus 1 minus 2 plus 1 plus 1, and hence you get 2. Now when you get 2, you understand if you are dividing two polynomials and divisor is a linear polynomial, in this case x minus 1 was linear, then 0 of divisor polynomial, which is x minus 1, will give you remainder. So it is very interesting fact, right? Whenever you try to divide any polynomial with a linear polynomial, you should try to find out what is 0 of that linear polynomial. And if you get 0 of the linear polynomial, just replace that value to the variable of your divisor polynomial, and your output of doing this is basically your remainder. And this is a very interesting fact, right? And this is the logic on which your remainder theorem is based on. So we'll go to remainder theorem now. Let's assume Px be a polynomial of degree greater than or equal to 1, and let a be a real number. If Px is divided by a linear polynomial x minus a, then the remainder is nothing but Pa. Thanks for watching. You can visit us on www.classesfun.com.